All right, welcome to week 4 or module 4 in IT1050 Fundamentals of IT. I'm just going to give you a little heads up for the week, what to expect in terms of our agenda, and a little kind of overview or introduction to what you'll be seeing this week. All right, so big picture, I want you to review the materials, read the pages, watch the videos, and learn about internet, the structure of it, some of the history behind it, and some of the figures of it. We'll be going deeper into packets and switching and things like that in coming weeks, but for now, big kind of pictures. We're going to be dipping our toe into some basic programming in this course, including Python and Java, and though we can argue later whether or not HTML is true programming or not, we'll see HTML, CSS, and JavaScript. I'll talk a little bit more about that kind of differentiation. As well, we're going to talk about the research project for your big term assignment project. And I want you to think about a topic that you might spend a few weeks on developing, building, creating, researching, etc. You might think about the effects of screens on learning, cybersecurity careers or topics, future of work in AI, whatever, something that should be connected or related to this course. Okay. So what you'll submit this week is a fairly simple, straightforward Python assignment, and you'll take the quiz on the basics of the internet networking, and you'll submit a topic and thesis statement, just a kind of theory, proposal, opinion on what you're going to be doing in your research project. So fairly straightforward and simple. Let's jump into a little introduction to Python, and then I'll talk a little bit about the networking module as well. So there are an enormous number of languages, and there's quite a history of languages and programming languages out there. And though we won't dive deep into it, just being a little bit aware of what programming languages are and how they work is important in this course. And so we're going to do a little bit of introduction on each of those pieces, okay? Certainly there's a history going way back, even to the days of Lady Ada, programming on a weaving loom, right? They used various punch cards, etc. But we're going to be really talking about kind of the more current languages. If we think back for a moment on kind of the origins of large computing machines and what they did, you can see in this graphic that people are not typing at a keyboard, nor are they looking at a monitor, right? They actually are cabling instructions with vacuum tubes and things like that. And so computing long ago looks very different than it is today. And so you had to have much more technical knowledge and awareness of what actually you were asking a computer to do. As kind of history moves along, we are more and more abstracted. And what that means is simply that we're familiar that computers use binary of some sorts, the zeros and ones, to send signals and messages and instructions over circuits. And most of us can't read that quickly in binary, so instead we might convert it to some machine language, etc., that the computer can use. But we actually program might look something more English-like. This is an example of a small small program in C, and when it is compiled for the machine to run, it actually might look like something like this in hex, and that's because computers can move through this much faster than they can plod through the English language. So we write it in one instruction, and a program or a compiler or an interpreter will convert it to a language that makes sense for the computer. Okay? And the reasons for this, of course, is that computers had a limited amount of memory. And so although we could write instructions in something that would make sense, computers could store it in ones and zeros and run it faster if they didn't have to interpret it back and forth. As you look at this, you could probably read and follow and understand a little bit of the instructions here, but might be harder for you to read or interpret hex just on the fly. As computer languages became more evolved, the C language we just saw was developed in the late 60s and early 70s. And this is an example of a Coco 2, a TRS-80 color computer 2 sitting on somebody's desk at home with a television set for a monitor. And this probably would have been maybe late 70s, early 80s is when we had one. Here's 1982 is the copyright under the Coco 2 language. And we can see that the instructions on the screen are much more clear and understandable to read. And so with each iteration of languages, the instructions become much more abstracted, right? We hide away the details of what's actually going on under the hood, and instead we let the computer do the work. Okay, so that's the same in this new language we're going to talk about called Python, where we're going to write instructions that seem very much English-like and don't need to worry so much about what goes on behind the scenes. So a little bit of introduction really quick. You're going to be writing in code or source code. Those are the English language instructions. And when you compile it or convert it, it's going to run in something called machine code. Syntax is just a fancy word for the rules of the language, right? So if I were to say, let's bake a cake, we'll mix eggs and gasoline, stir, bake at 350, and then preheat the oven to 425. I understood all those instructions, but they might not make sense to me, right? So the syntax of the language can be understood, but the instructions must also make sense as well. So we have rules of grammar, for example, of how to speak that make sense to us, that we can understand and talk back to each other. If you've ever taken a Spanish or French or German class, you've had to study closely the rules of the language to make sure that there's verb, subject, agreement, etc. When we talk about output, that's simply what the computer is sending out. So that might be on the monitor or screen. If you think about a Kroger self-checkout machine, the coupon and the receipt, those are outputs as well as the speaker noise that comes out. And when we talk about console, you might hear this term or CLI or terminal. What we're really talking about is the interface or one of the interfaces on the computer, and specifically a simple text window like you might see here to the right. I mentioned it before that we'd have to convert to some kind of instruction or some kind of machine code for the computer to run. And so earlier languages might have used a compiler. So we would write in source code, convert it to a bytecode in Java, and then when we execute that program, the computer is actually using this different file that it can understand better. Okay, that's old compiling languages. And Python is used in a slightly different way, and it's uses an interpreter, so that doesn't truly convert it, but it kind of runs it on the fly for the computer to see that. And you can imagine why that's the case, right? As computers have become more powerful and had more and more features and larger memory, then we don't longer have to worry about limitations of RAM. When we have 16 gigabytes of RAM and 3.2 gigahertz on a computer, computers are much more capable than they were years ago. So not unlike rewiring that computer in that great big ENIAC that took up a whole office building or whatever, these desktop computers that you're running are so powerful and so fast that they can actually do some of the work for you, and you don't need to worry even about that intermediate step that we had in Java. So here's a couple examples of writing expressions in Python. These are going to start with basic mathematical operations or arithmetics, and we see there's a few set of rules like what an expression looks like, some of the tools we might use like the actual arithmetic operators, plus, minus, multiply, which is not the X or the dot, but actually an asterisk. That's Shift 8 on your keyboard, and the / key, which is underneath the question mark on your keyboard in the lower right. Other ones are exponentials. So these expressions might look, depending on the language, like 2 asterisks, an up caret, which is above the number 6 key, or even POW for power, and there might be a number on either side. This last one is modulus or modulo, which finds the remainder of a division problem. And that's helpful for things like grouping sets or even finding out odd and even numbers. Lastly, precedence is simply order of operations, like PEMDAS you may have learned. And that's simply that there is a logical sequence to how you solve, or a computer might solve or work an expression. For example, the difference between 1 plus 3 times 4 versus parentheses 1 plus 3 times 4 would have different results. Okay, print statements. So the most common piece here is the statement method or function called print. Notice that it's followed by parentheses to indicate that it is an action, a method, a function word. And then we wrap inside of it either specific words enclosed in quotes, double quotes as you see, or the parentheses wrap around numbers or variables. So if you put quotes around it, it'll print exactly that. If not, it'll try to solve or express what you've put in it. So here down below is an example. Print quotes hello world, age equals 45, and then print quote you have, then a comma, 65 minus age, then another comma, years until retirement. So what we're doing there is a concatenation or joining of multiple expressions in one single statement by having you have printed literally, and then it's going to solve the difference of 65 minus 45, and then print again years until retirement, and that appears as you have 20 years until retirement. A couple other quick ones. A variable, like you learned in algebra class or whatever, or like an x or y or whatever, is just something that can hold and change value. We often use that in computers and programming simply to explain or represent a number or a value that may change over time. For example, here we have x equals 5, and this expression works essentially right to left. We take the value of 5 and put it into the variable called x. So we set x equal to the value of 5. GPA equals 3.14. So we could print GPA and we should get out the value 3.14. And then lastly, input. An input is taking input from a user. So we might also call that a prompt. So we'd say, let's create a variable, we'll call it age, and set it equal to the result of calling input. And we'll give the user a prompt, how old are you? Then we'll print their age, your age is, and combine it or concatenate it using the comma with the variable word age. So what we'll see is we get a prompt, how old are you? Then the user types in the number 53, and then the computer prints back, your age is 53. Likewise, we have another concatenation, you have 65 minus age, years until retirement. Well, if the user typed in 53, then they'll calculate the difference, 65 minus 53, or 12. Okay, so the number of options that we can have here. We'll flip back quickly to the assignment in Canvas. And we've got a fairly simple Hello World assignment. We've already downloaded Python, and hopefully by now you've downloaded Thonny. So if we run Thonny, it might look like this. Again, I'm using a Mac, so it has a slightly different user interface or UI than Windows. Windows is going to have the 3 buttons over here, but essentially you should have a very similar layout and screen. Up top we have the editor. This is where we're actually going to type in our program, and down below we have the shell that executes or runs that program. So let's do a very basic program. We'll call it Hello World, and we'll just do a function called print. In there, we're going to pass the parameter argument, making sure to wrap everything in parentheses, and inside that, wrap everything in quotes. I'll save that as hello, and my computer needs the file extension to know what kind of file this is, so I'm going to add py to the end of this program, and notice it prompts you here. Py is short for Python. And then I can run that program as is. And as that program runs, you see the command down below, %run, hello.py. It's looking for that file, hello.py, and it prints out hello world. The nice thing about Thonny is it has the IDLE kind of behavior built in. This lower half is called the shell, and with these three little greater than symbols, we can test things on the fly without having to print, save, and run every time. So if I just wanted to check, well, can I print just a number like so, and it prints out. Can I print a sum? Print parentheses 5 plus 6. What if I wanted to print 5 and then 6? Well, print parentheses 5 comma 6. What would that print? It would print 5 and then 6 after it. Now notice what happens here is that comma actually adds a space in there. Okay, there is a way to backspace that and things like that, but we will not pay attention to that right now. So let's say I wanted to ask for your name. I'm going to create a variable above this statement. So I'll just say, hello, who are you? And then I might have a variable called name, and I'll set it equal to the result of calling the command input. And inside the parentheses of that input, I can give users a prompt or a little guidance. And so we'll say, enter your name, and then leave a little space after the sentence. So it just kind of feels from a user interface perspective like there's some room. And then I might come down and do another print statement. And I'll concatenate or join two phrases or two expressions together. And it might be hello, comma, then a space. I'll close the quote. And this comma is just part of a sentence structure. But now a comma outside that is going to say, okay, let's join these two elements together. So in this case, I have a literal string because it's going to print literally what's inside the quotes. And then I'm going to print the value of what is stored in name. Now, right now, there's nothing in name. So if I came down here and said print the variable name, it might be confused because we haven't even created that program, and it actually throws me an error. So if I save my program and run my program with this green dot, then it says, hello, who are you? Enter your name. I'll put my name in. And what I've done is I've typed in after the prompt. So when I hit enter, it'll activate this action here and save whatever I've typed into the variable name and then print that out. Great. Okay. One more thing I'd like to show is the idea of a comment. So there's a couple different ways to do comments, and comments are just sections or lines of text within code that the computer will essentially ignore, but it helps users and future users understand who wrote the program, the intent of the program, etc. So I'm going to add a comment here with my name. I'll add another line and just say my first Python program. That's what I'll call it, even though it's not my first. Let's make sure I can actually type. And it might be helpful just to have the date. So we'll say September 13th. And then I can continue on. Now there are all other types of comments, and we'll come back to that briefly, but I just wanted you to get in the habit of using a single line comment using the # or the hashtag, whatever you want to call it. And if I save it and run it again, there's largely no difference to the program, except when I see this code later on, I'll understand at least who wrote it, how old it is. If I wanted to explain something, for example, I could have a comment right above that says input method allows users to enter information. It saves to a variable on the left side of the expression. Okay, and by expression, we just mean a single line of code or an intent here that might not necessarily be complete, but like x equals 5, we're saying set the value of whatever the input was into the variable called name. Okay, so that should get you started. You've got a little assignment in Canvas. Certainly reach out. If you need any assistance, this should be fairly straight program. Probably the biggest challenge is just getting everything around the first time. There are other editors out there like Replit. So you Replit.com. It requires a user login. It might not require a Python installation. But I would avoid for now full IDE editors like VS Code and things like that. And the simple reason is the autocomplete and AI tools are not something we're going to use right now. So I want you to do this on your own. Basic text editor, fairly simple, straightforward little program. You'll have instructions in the assignment. And take your time. You can do it. You'll enjoy it, I promise. And if you're looking for a great resource, as always, just like in other weeks, w3schools.com is a great resource to use because of reliability and currency. It is up to date. So check those out and have a great week. All right, take care.